So welcome students to week 6 or module 6, which is titled The Safe Workshop. I am recording this because I'm unable to meet with you guys this week. But I have got Dave in for Dave Ellis, who's coming in to talk a little bit more about this subject, but also it'll be an opportunity for you guys to talk directly with him about the practical workshop as well. Now, as stated in the message for the week, I'm not back until late on Wednesday night, which obviously interferes with our tutorial time, but also being aware that you've got assessment task 2 coming due. I'm very happy for you to reach out if you want to even have a quick one-on-one Q&A session, or if there's a few of you, we can reschedule to another time, maybe the Thursday or the Friday, or even over the weekend if required. But in any case, I'll work through what we're going to be talking about here today, and specifically, I'm going to be talking about this generically, but also in the context of the router, both the handheld portable router and the fixed table router, because that was something that I wanted you to have a look at in relation to part of assessment task 2. Okay, so the secondary school workshop context is quite unique in that, in addition to yourself as the teacher, you also have 20 or so young people present. Now, students are usually very happy and excited to be in the workshop for practical lessons. However, this can present a range of challenges for you to manage, and they're fairly unique, I suppose, when you think about it. A key to success and your sanity is to develop and maintain a safe workshop culture. But what does that actually mean? So if we think about a definition of culture, it's the ideas, customs, and social behaviour of a particular people or society. This suggests that developing a safe workshop culture is not a simple or straightforward process due to the different ideas, habits, and knowledge of individual students and teachers. There won't be a one-size-fits-all approach. So it's something that you kind of will have to develop yourself in the context in which you find yourself. You may already have significant experience in a school workshop environment, or it might be a goal that you're working towards. Discussing and sharing your experiences and understanding with colleagues is a valuable endeavour. We will seek to discuss and share our experiences in this week's tutorial. And that's kind of something that you can do with Dave, because he's very experienced in schools. And so, if any of you do have some experiences you can talk about, that's great. But certainly Dave is a wealth of knowledge. Now, this is already on the in the module. So the 4 areas of safety, and these are areas that we need to consider, particularly as teachers. So we'll start with personal safety. So shoes need to be solid leather shoes, and they're your shoes as well, not just students. Certainly in New South Wales Department of Education schools, that's been pretty much on the book since about 1880. That school students should be wearing solid leather upper shoes, not just in the workshop, but to school full stop. So, if you're in a school where that is not the culture, that's probably something you need to have a serious look at. Clothing should not be loose and dangling. Hair should be either short or tied back so that it does not get caught in machinery. Face shields should be worn to protect the eyes and face. Earmuffs should be worn to protect the ears from excessive noise. Now, they're very generic things, so that's not saying that as soon as you go into the room you should put face shields and earmuffs on, but in certain contexts that would be appropriate. Tool and equipment safety is the other one, or the second one, I should say. So it's using tools and machines in the correct manner. So tools and machines should only be used for the purpose for which they are intended. They should not be left lying around. Clutter can lead to accidents. So again, if you're finding that your workshop culture is to have a messy workshop, that is something that you should seriously look at. Circuit breakers should be installed on all electrical equipment, and guards must be positioned as required and not removed. Machines should be safe to use, so no frayed cords, broken parts, etc. Cords should not be stretched across a room or be in a position where someone can trip over them. So again, particularly in busy workshops where there might be a few processes happening, it needs you to be planning for that and working out that you have machines in the right location, and you've got cords in the right location as well. Work should always be held firmly. All drill bits and router cutters should be properly tightened, and fingers should not be placed behind any cutting edges, whether they're handheld chisels, saws, or machines. It's a good general rule of thumb. Okay, general room safety, and this is where some fairly unique sort of situations can come up that are fairly unique to teachers. So workspaces and access areas should be kept clear. Consideration should be given to others working in the room, meaning messes clean up as we work and tools are returned to where they belong. Broken tools should be reported and not used. And effectively, they should be at that point removed from the room. They shouldn't be left there. Again, work should be held firmly. There should be no running in the room, distracting others or pushing past others who are working. This may cause injuries. And this is really one of those things that's quite unique to the school environment. I've had situations where I've had students run in the room and there's been near misses because of that. It's just something that's just simply not done. And then, we're going to talk about this a little bit later as well. We're going to talk about risk assessment, but we're going to talk about localized risk assessment. So that's an ongoing risk assessment. And that's where, something might happen on a particular day, or you might just be thinking about a process that's coming up for a particular project, where you're assessing and thinking about the risks of that. And we're going to talk about that a little bit more specifically in relation to the router. And this is quite common, and this is something that I do a lot, and it might involve changing a process or constructing a jig, or it may be as simple as putting things in a different place or holding things in clamps and vices. I, for one, am a jig aficionado. I'm quite keen for a good jig, where I can either make a process easier and definitely make a process safer. Okay, so I'm just going to go through a summary of work health and safety legislation, and it's important to have an understanding of it because the reality is the Work Health and Safety Act in your state does very much apply in the workshop situation. So the Australian Government has put work health and safety legislation in place that stipulates that employers will provide a safe working environment for their employees. This involves ensuring work practices are safe and do not pose a threat to the health of workers, ensuring that all tools, equipment and machinery are in safe working order, ensuring that the handling, storage and transport of hazardous materials is carried out safely, and ensuring that workers are adequately trained and there is safety information signage throughout the workplace to help avoid accidents. So, before I go on there with further, it's an interesting sort of thing because you are both an employee of your school, but in a sense, you also have a position of authority over the student. Now, the student is not an employee of anybody. In fact, they are a child. So, it kind of does put you into an interesting situation where you do still very much have to both take the role of the employee. It's obvious that your employer can't put you into a dangerous or unsafe situation, but also that you have a duty to ensure that you're not putting students into dangerous or unsafe situations as well. And of course, the legislation provides for consultation with workers and their representatives about safety concerns. And you would be aware of that in terms of, in your particular school, there will be a work health and safety committee in your workplace. Regularly checking and monitoring the workplace for safety hazards and keeping adequate records of procedures. So as mentioned, all workplaces are expected to have a WH&S committee that will ensure that the organisation has adequate safety policies and safe working procedures. So basically, like, you are part of that anyway, because you are obviously going to be developing and maintaining safe working procedures in your classroom with your students, but also that sort of flows down from the work policies and safe working procedures that are developed by your employer. The committee also needs to be aware of the safety and health issues related to that organisation. And so you would be relating to the committee and also feeding them information in terms of if you had any safety queries or concerns. And their role is to advise management on risk reduction in the workplace, and also to check working procedures for hazardous practices. So it is actually a good process to have your own practices audited from time to time, just so that somebody else can have a look and make sure that that appropriate protocols are being followed. And also to provide training. So it is your employer's responsibility to ensure that you are properly trained and to resolve disagreements or problems. Now, employees also have responsibilities under the Act, so that's you. As an employee, you must take reasonable care of yourself, avoid anything that would affect the health and safety of others at work, and follow any reasonable health and safety instructions from your employer. It is important that you work safely, follow instructions, ask for clarification if you're not sure how to safely perform the work, use personal protective equipment in the way you were trained and instructed to use it. And just as an aside on that, that's also important to make sure that you're always modelling that to students as well, that you would use personal protective equipment exactly how you require them to. Report injuries and unsafe or unhealthy situations to your supervisor or to your health and safety representative. So usually that would be, your supervisor will be your head of faculty. Breaches of the legislation can result in penalties for an individual and the business. Okay, so now I'm going to talk through really sort of fairly quickly the risk management process. Now, a lot of this stuff, this information is it's generic, and you can find this from information from at WorkCover or various other sort of safety bodies that related to the government of your state or federal government. So there's no secrets in any of this. So risk management is an ongoing process of identifying, treating, and then managing risks. Taking the time to set up and implement a risk management process is like setting up a fire alarm. You hope it never goes off, but you're willing to deal with the minor inconvenience up front in exchange for protection down the road. There's 4 steps. So a safe and healthy workshop does not happen by chance or guesswork. You have to think about what could go wrong in your workshop and what the consequences could be. You must then do whatever you can, in other words, whatever is reasonably practicable, to eliminate or minimise health and safety risks arising from the task or process being undertaken. This process is known as risk management and involves 4 steps. So firstly, you need to identify the hazard. And find out what could cause the harm. The second one is to assess the risks if it's necessary. Understand the nature of the harm that could be caused by the hazard, how serious the harm could be, and the likelihood of it happening. And then control them. So implement the most effective control measure that is reasonably practicable in the circumstances. Review the control measures to ensure they are working as planned. So it's not good enough to sort of put up say, well, this is our operating procedure for this particular process, and that's how we've managed it. If no one's going back to check and review it. Pardon me. So many hazards and their associated risks are well known and have well established and accepted control measures. In these situations, the second step to formally assess the risk is unnecessary. If after identifying a hazard, you already know the risk and how to control it effectively, you may simply implement the controls. So risk management is a proactive process that helps you respond to change and facilitate continuous improvement in your workplace. It should be planned, systematic, and cover all reasonably foreseeable hazards and associated risks. Now, one of the things I'll be talking to you about in a little bit, when we're talking about a particular process on the router, is if you don't have an experience of that particular process on the router, then you might not be aware of the risk. And so that's where your own training comes into it, but also that consulting with colleagues as well, particularly those who have experience. Now, all of this is from the perspective of the owner of a business, or perhaps the principal of your school. We've already sort of looked at questions about responsibility, like what's the employer responsible for, what's you as the employees responsible for. But as I mentioned before, you as the teacher are somewhere in the middle. You are certainly an employee and therefore have responsibilities under the Act. However, you're also responsible for students in your care and may need to consider the responsibilities of your employer. You may therefore see yourself as somewhere in the middle. All right, so how to perform a risk assessment. So all hazards have the potential to cause different types and severities of harm, ranging from minor discomfort to serious injury or death. For example, heavy LPG gas cylinders can cause muscular strain when they are handled manually. However, if the cylinder is damaged, causing gas to leak, which is then ignited, a fire could result in serious burns. If that leak occurs in a storeroom or similar enclosed space, it could result in an explosion that could destroy the building and kill or injure anyone nearby. Each of the outcomes involves a different kind of harm with a range of severities, and each has a different likelihood of occurrence. Assessing the severity of a potential hazard, how the hazard may cause harm, and the likelihood of the harm occurring are all components of performing a risk assessment. The following headings outline what to consider for each of these components and useful questions to ask when assessing the risk. Now, one thing I won't go into here, and some of you guys might have already seen it, is the risk assessment matrix. I don't actually go into it here, but you can access that information about risk assessment matrices, which is kind of like a little table, from your sort of local government authority that deals with health and safety. Okay, so work out how severe the harm could be. To estimate the severity of harm that could result from each hazard, you should consider the following questions. What type of harm could occur? For example, muscular strain, fatigue, burns, laceration. And, to put that into the context of a router, basically you've got a spinning cutter that's spinning quite fast. And generally the major risk there is fingers becoming into contact with a spinning cutter. So that's that will give you a bit of idea about the harm that could occur. So for example, that sort of harm might in the vast majority of cases not be fatal, but it certainly could cause a very serious injury. How severe is the harm? Could the hazard cause death, serious injuries, illness, or only minor injuries? So again, talking about the router, we've talked about generally, the type of harm is probably fingers coming into contact. We've talked about the severity of the harm as compared with, if fingers came into contact with the disc sander or fingers came into contact with, the bandsaw. That there's different kinds of severity there. So what factors could influence the severity of harm that occurs? The distance someone might fall, or the concentration of a particular substance. And in the case of, say, a router, that might be the kind of cutter that you are using, or the kind of process that you are undertaking. How many people are exposed to the hazard, and how many people could be harmed in and outside of your workplace? So again, usually when in the workshop, it's usually in the case of individual injury, but certainly there are situations where it could be multiple injury. For example, dust over a long period of time, or some sort of chemical is possible, or it could be something like electrocution or those sorts of risks where you might have more than one person could potentially be injured. When it comes to most sort of machinery situations, it's generally a one-person situation that you're thinking of in terms of how many people could be injured. Could one failure lead to other failures? For example, could the failure of your electrical supply make any control measures that rely on electricity ineffective? And could a small event escalate to a much larger event, with more serious consequences? So minor fires can get out of control quickly in the presence of large amounts of combustible materials. And then work out how the hazards might cause harm. And that's what we will be talking about a bit when we do talk about routers. So in most cases, incidents occur as a result of a chain of events and a failure of one or more links in that chain. If one or more of the events can be stopped or changed, the risk might be eliminated or reduced. One way of outlining chain of events is to determine the starting point where things begin to go wrong, and then considers, if this happens, what may happen next. This will provide a list of events that sooner or later cause harm. So in thinking about how each hazard may cause harm, you should consider the effectiveness of existing control measures and whether they control all types of harm, how work is actually done rather than relying on written manuals and procedures. And I think that one's particularly relevant for the school situation. So it's one of those things where you might set up a process, but then find that for whatever reason, students aren't following the process and they're doing something a different way, and that might then be introducing risk of harm. Infrequent or abnormal situations, as well as how things are normally meant to occur. Now, again, looking at the school situation, you might have students doing independent design elements. So there might be one student that requires a particular process to happen, and it's a process that you don't necessarily do that often. That's where you might have an infrequent or an abnormal situation. And speaking from personal experience, sometimes you can find yourself in a situation where you're having to make lots of sort of micro decisions that relate to, how to be safe in a particular situation. And sometimes you might end up feel like you're making too many of those. And I think that's always a good sign to either stop whatever it is that you're doing, and maybe, even have a talk to the students about slowing things down a little bit, and putting in some time to actually consider how to do something safely rather than rushing to get things done. And of course, consider maintenance and cleaning, as well as breakdowns of equipment and failures of health and safety controls. So then the likelihood, we can talk about these serious harms, but what's the likelihood of it happening? So the likelihood that someone will be harmed can be estimated by considering the following. How often is the task done? So for example, if you've got a lot of students using the disc sander all the time, maybe that will increase the chances of a finger coming into contact with the disc sander, maybe. Does this make the harm more or less likely? So again, if you've got well-trained students, or you've got a good, safe work culture, the fact that the students are using the disc sander a lot might mean that it actually makes it less likely, because they're becoming experienced and responsible users of the disc sander. How often are people near the hazard? How close do people get to it? And you might also say, how close do parts of people get to it? So that's something that we really need to think about in the workshop in terms of particular processes. How close do our hands get to the cutter or the drill press or the pad on the disc sander or the bandsaw blade? That's really one of those things to consider. Certainly in terms of operational risk mitigation or harm minimisation, one of the key things is to work out ways to keep hands away from where the action is. Has it ever happened before, either in your workplace or somewhere else? And that's where, particularly if you're new, consulting with those who are more experienced is a good thing to do. And how often? You can rate the likelihood as one of the following: certain to occur, and this is where we're talking about this risk management matrix. Expected to occur in most circumstances. Very likely, will probably occur in most circumstances. Possible, might occur occasionally. Unlikely, could happen at some time. Rare, may happen only in exceptional circumstances. The level of risk will increase as the likelihood of harm and its severity increases. The most important step in managing risk involves eliminating them so far as is reasonably practicable, or if that is not possible, minimising the risk so far as is reasonably practicable. Now, this is sort of something important to consider, because if you think about workshops in schools, well, the best way to eliminate the risk is to not have workshops in schools. And to be honest, there's probably some principals in some schools who have pretty much taken that approach. However, number one, syllabus documents in all states require workshops, the students to have access to practical workshops to fulfil the requirements of a range of syllabuses. In New South Wales in particular, with industrial technology, it's actually required for students to have access to workshops to be able to fulfil the requirements of that particular course. So in that case, we're generally, there will be some elimination will go on. So for example, we don't let students use the table saw because the likelihood is there and the severity is there as well. So we eliminate that particular risk by not allowing students to use it. It does mean that teachers have to use it probably a little bit more, and that can actually increase the risk to them to some extent. So in deciding how to control risks, you must consult your colleagues who will be directly affected by this decision. Their experience will help you choose appropriate control measures, and their involvement will increase the level of acceptance of any changes that may be needed to the way they do their job. Now, there are many ways to control risks. Some control measures are more effective than others. And you must consider various control options and choose the control that most effectively eliminates the hazard or minimises the risk in the circumstances. This may involve a single control measure or a combination of different controls that together provide the highest level of protection that is reasonably practicable. Some problems can be fixed easily and should be done straight away, while others will need more effort and planning to resolve. Of those requiring more effort, you should prioritise areas for action, focusing first on those hazards with the highest level of risk. So I brought an image in here as well, which shows then the hierarchy of risk control, which we're going to talk about. So the ways of controlling risks are ranked from the highest level of protection and reliability to the lowest, as shown in the adjacent image. This ranking is known as the hierarchy of risk control. Work health and safety regulations require duty holders to work through this hierarchy when managing risk under work health and safety regulations. The 3 levels of risk control are shown in the following images and outlined further under each of the headings that follow. Okay, so let's have a look at that. So you must always aim to eliminate a hazard, which is the most effective control. If this is not reasonably practicable, you must minimise the risk by working through the other alternatives. And like I said before, if you want to eliminate the risk of injury in the workshop, then eliminate the workshop. Simple, done. But we're all out of a job. But more importantly, the students do not get the experiences and the learning environment that the workshop offers. So we need to go beyond that. So there are some things, like I said, that we will eliminate, but it's not reasonably practicable. So now we've got to minimise. So level 1 control measures, eliminate the hazard. Don't introduce the hazard into the workplace. For example, you can eliminate the risk of a fall from height by doing the work at ground level. Eliminating hazards is often cheaper and more practical to achieve at the design or planning stage of a product, process or place used for work. In these early phases, there is greater scope to design out hazards or incorporate risk control measures that are compatible with the original design and functional requirements. For example, a noisy machine could be designed and built to produce as little noise as possible, which is more effective than providing workers with PPE or hearing protectors. You can eliminate risk by removing the hazard, by removing trip hazards on the floor or disposing of unwanted chemicals. So it may not be possible to eliminate a hazard if doing so means that you cannot make the end product or deliver the service. If you cannot eliminate the hazard, then eliminate as many of the risks associated with the hazard as possible, which is where we are. But you can see some good examples there, how like in the practical day-to-day, you can eliminate hazards. Keeping a clean, well-organised workshop eliminates hazards. Keeping your tools sharp and in working order, good working order, eliminates hazards. Generating and creating a safe workshop culture eliminates hazards. So level 2, if it's not reasonably practical to eliminate the hazard and associated risk, you should minimise the risk by using one or more of the following approaches. Substitute the hazard with something safer. So replace solvent-based paints with water-based ones. A fairly common one in the workshop would be where a student wants to cut something using, might be using the drop saw or something like that, or using the bandsaw, but the piece of timber is fairly small. So you can now replace that with something else. You can say, okay, well, because the timber is so small, it means that your hands will get too close or you won't be able to use the clamps. Therefore, cut it by hand. The other way you can, going back a level by eliminating that hazard, is you can say to students, don't do any process that means that your particular piece of timber is so short or so small that you can't cut it safely. So usually what I would say is never cut anything to length until you've done everything else you need to do on it first. So you can both eliminate a hazard there, but you can also substitute it with something safer. Isolate the hazard from people. So physically separate the source of harm from people by distance or using barriers. So guardrails, that sort of thing. Remote control systems in extreme cases. Put your chemicals away in a fume cabinet. Use engineering controls. So an engineering control is a control measure that is physical in nature, including a mechanical device or process. For example, use mechanical devices such as trolleys or hoists to move heavy loads, place guards around moving parts of machinery, install residual current devices, safety switches, set work rates, that sort of thing. Now, in terms of an engineering control in our context, a jig is an engineering control. So, for example, if you've got a process where you might think students' fingers are getting too close to cutters, you might design and construct a jig that can hold the student's job, and then the student can control the jig rather than controlling the particular component, and it can keep their hands a long way away from the actual cutters. So that's an engineering control. And then level 3 control measures. So they don't control the hazard at the source, so they rely on human behaviour and supervision, and used on their own tend to be the least effective in minimising risks. So 2 approaches to reduce risk in this way are use administrative controls, so work methods or procedures that are designed to minimise exposure to a hazard. So, for example, develop procedures on how to operate machinery safely, limit exposure time to a hazardous task, and use signs to warn people of a hazard. Now, that's quite interesting because in the school workshop, number one, there's lots and lots of signs up around. There's signs that should be there for basically every machine. There should be a safe operating procedure, which we're going to have a look at in a couple of slides. But also we do safety tests with our students, and we put this great deal of sort of focus on safety testing and signage and all that sort of thing. But you can see here, they're basically saying that these are the least effective ways of minimising risk. Now, that's not to say don't do it. Like, it's important to do, and certainly it's very important when it comes to developing safe working cultures. But just be aware that safety tests and having some signs up are the least reliable of ways of mitigating and controlling risk. Use PPE. Now, again, we put a lot of focus on using correct PPE. However, it is one of the least effective ways of reducing risk. So it limits exposure to the harmful effects of a hazard, but only if it's used properly. So earmuffs, respirators, face masks, hard hats, gloves, aprons, and eyewear. Now, for us, it's mostly eyewear and ears, as well as aprons, and making sure we don't have loose, dangly clothing. Generally, in the woodwork shop, gloves are a no-no because they can actually get caught in machinery. So administrative controls and PPE should only be used when there are no other practical control measures available as a last resort, as an interim measure until a more effective way of controlling the risk can be used, and to supplement, and that's really how we use it all the time, to supplement higher level control measures. So for example, we would say, when using routers, because they can be quite noisy, we'll have hearing protection on. But you might find yourself in a situation where, you might be trying to source either quieter routers or quieter cutters or, different processors so that that's less of an issue. The other one is, dust masks are good as a sort of a support measure for the dust extraction system that you would have. Okay, so we're going to look at a scenario, and I've actually got a video up there on the in the module that relates to this. So think about this. So it's a June, and this is a real scenario that I sort of experienced. It's the June-July school holidays, and you're thinking about the second half of the year, and the Year 9 timber or resistant materials class. Now, in the second half, they usually make a small table. It's a really good project. Students enjoy it, but in this particular case, it used dowel joints to join the rails to the legs. And what I've, and this is true, I can speak about this in the first person. I found a couple of problems with it. And one of the problems was the students did have some issues getting their dowel joints properly lined up. And the thing with a dowel joint as compared with, say, a domino or a biscuit is it can be a little bit unforgiving if you don't get things lined up properly. But the other one is, particularly if they didn't glue it up properly, it often wasn't that strong and could fall apart. So, so the scenario is, I'm thinking I would like my students to learn how to make and use a mortise and tenon joint. And it's a much more appropriate joint, in my opinion. And then I thought, Well, I'd like them to use the portable plunge router to help cut the shoulders on the tenons because it will give them experience with the router. However, I've got concerns about the safety of my students because the router can be dangerous if mishandled, especially by careless students. So there is a video in the module there that sort of shows you a way that a router can be used in this process. But in any case, it's worth having a look at that so you can see what I'm talking about there. Now, I've got here from the Victorian State Government a safe work procedure, and it's a generic one for a plunge router. And so it identifies what the potential hazards are. It talks about what PPE is appropriate. So you've got eye protection, you've got appropriate footwear, which, in the school situation would be solid leather upper shoes, hearing protection, yes, because they're quite noisy, and protective clothing such as an apron to make sure that there's nothing that can get tangled in the router. Now you'll see there is a checklist, and this is quite standard for a safe work procedure checklist. So you make sure the task is clearly understood. Now this really needs to have, honestly, that particular dot point there needs to have a whole lot more underneath it. Okay, and I'll just come back to that in a minute. Ensure appropriate guarding is in place. So, the router will come with the appropriate guarding and need to make sure that it's not removed. Ensure the desired router bit is, inserted and securely and properly installed. It's set to the desired height. The workpiece is securely clamped. You know where the on-off switch is and the emergency stop button. Particularly when you're holding the router, a lot of the good routers will have a pressure switch on the handle. So when you're holding the handle, you can hold the switch down at the same time. Have complete control of it. In terms of operational, check that the bit runs true and does not wobble. I could tell you now that if a router bit was wobbling, I'd be wanting to get that thing turned off, taken out and thrown away real quick. Keep hands clear of workpiece and away from routing blade. Yeah, and that's one of the big ones in terms of you want to make sure that the workpiece is clamped. You do not want to hold the workpiece with your hand. Turn the machine off at power point if changing the bit. I actually go further than that. I actually make sure it is physically disconnected. Particularly if you're thinking about the context of a busy workshop, you wouldn't want to have somebody come along and flick that switch without your knowledge. So I actually physically make sure that is not plugged in. Exercise care when removing bit as it may be hot. Post-operation, switch router off before removing waste material. Ensure good housekeeping practices are in place to minimise dust buildup. Return router bits and router to storage area. One other post-operation thing I make very clear to students is when they have finished the cutting process, particularly if they're using a handheld router, they will come to the end of the cutting process and they turn the machine off and they do not move the machine until the router bit has stopped rotating, because what can happen is they can finish the cutting process and then in the process of to put the router down onto the table on its side, they can expose the cutter either to another person or to the power cord. So I always say to them is finish the process, make sure the router is not in contact with the job, turn it off, but do not move it until it stops rotating. Now going right back to the first dot point under pre-operation task, this is kind of the link between a safe work procedure and a safe work method statement. So what a safe work method statement should focus a little bit more on are the particular processes that might be undertaken. Okay, so, and we're going to talk about that very, very soon. In fact, I think it's on the next slide, in terms of something that's, relevant to you guys. So what is the particular task that is being done? Because the thing is that a router, depending on what the task is, a router can behave in different ways. And therefore, different controls need to be put into place depending on what the actual process is. Okay, so we'll go to the next slide. And so there's two images here. So again, here's another safe operating procedure. This is actually one that I have developed myself. So this is one that I've made for my school students. But what you will see there, a lot of it is just formatting, because it's got the same sort of similar information that was on the other image before, the other document. But what I've done is I've put some things that are particularly relevant to my own environment. So you might see a bit of some differences there. So safety glasses, leather footwear, no rings or jewelry, long and loose hair must be contained, close-fitting protective clothing must be worn. Okay, so that's, and no gloves. Now, in my particular case, I've put, make sure there's no slip hazards or trip hazards. The router guard is in position. Clamping procedures to ensure work is secure. Do not use faulty equipment. Check material for faults or defects. So that wasn't mentioned in that other one, but I think it's fairly relevant. Fit cutter to machine and make all adjustments for depth of cut, guides and other attachments. And again, you'll see there's a few different ones here. So never leave the router while it is running. That wasn't mentioned before, but I put it in there because it has happened. Never leave the tool switched on and turn the power off at power source. Before making adjustments or cleaning swarf accumulation, switch off and bring the machine to a complete standstill. Remove keys or spanners from tool. Hold router with both hands. So you can see that wasn't mentioned there. Keep fingers, hands and power cord. That wasn't mentioned in that other one. And again, I have had a situation where the power cord did come into contact with the cutter, and the safety switch dealt with it. Allow motor to attain full speed before use. Keep sole plate pressed firmly on the workpiece. Turn motor off as soon as cut is finished. Like I mentioned before, do not place machine down until the cutter has stopped rotating. Feed along at a sufficient rate to keep the bit cutting. Use a safe working posture with a stable stance. So you can see I've actually got more information in there than the other one, because that's very, very specific to my environment and the fact that students are using it. And you can also see here, this actually becomes part of one of their safety tests. So each student will go through a safety testing procedure, and they will actually sign off and date that, and I'll keep that on my records. Now, the thing that I wanted to talk to you about here, this image here is the handle, or my design for the handle for the Tool Caddy project. And what you can see here, I've obviously taken away the sides. You can see the mortise that goes into the corresponding tenon in the sides of the Tool Caddy. And you can see that there is a curve here with a rounded over edge on the curve. So the idea of that is to have a nice comfortable handle, because I'm going to be holding it around about here in the middle. So I have a nice comfortable handle in my hand that doesn't have any sort of sharp edges to it. Now, one way that you could achieve this rounded over profile here is to use a round over bit on a router table. So again, I've got a video in there for you. It goes for about 10 minutes, and it actually demonstrates and shows you a router table that I think is going to be very similar to the one that you'll be using in the workshop. So you can get an idea of how it operates. But there are some safety issues to consider when cutting this round over here on the router cutter. or using the router table. Number one, because it's a curve, you can't use the fence on the router table to sort of guide the job, because obviously, you know, it won't cut down here because because of the curve. It's off the fence. So you're going to have to sort of freehand it against the cutter, which can be done. However, it does run into some risks, because let's say we're looking at this other side here and we're going to cut it. There's two things to consider there. Firstly, the cutter will be cutting, you know, going around in this direction, if you can see how the mouse is going, which means that you're going to need to feed the handle into the cutter. So you'll be going from the right-hand side to the left-hand side. So you'll be going from right to left. So that means the cutter will come along here and start cutting down here. Now, if for some reason the cutter grabs the workpiece, it's going to want to pull it from left to right. So if you are holding if you have your left hand out here holding the piece, and the cutter does grab the piece, there is a chance that it may pull the piece from left to right and also pull your hand into the cutter. So that's number one issue, potential issue. Now, from my experience, the chances of that happening on that particular part of the cut up here is fairly low, but it's not zero. The other thing that can happen is, because at this stage, in terms of grain direction, the cutter is kind of going down the hill. So it's going down the grain or with the grain. When we get to beyond the center of the handle, the cutter is now kind of going up the hill, and it's cutting into the sort of some exposed end grain. And what can happen there is, particularly if the cutter is not super sharp, it can actually get in under the grain and start to rip and tear it out. And so it can damage the workpiece. But the other thing that it does is it increases the chances of grabbing and pulling the workpiece. So we've identified a couple of issues here in terms of how would we set this up so that we can achieve what we want to achieve with the but without doing it sort of dangerously. Okay, so I'll try not to say everything, but I suppose, because I'd like you guys to think about it a bit, but I suppose one thing you could do is you could eliminate it. You could say, okay, well, I'll try to achieve it some other way. I'll achieve this nice round over some other way. So that's one way you could do it, perhaps. Now, I won't say, I could sort of suggest about 3 different ways you could do that, but I'll see if you guys can think of what that could be. Now, personally, I would persist with the router, because with the 3 other ways I can think of is that they either won't give you the best finish or the best finished result. That's number one. That they could be much more time consuming. That's another one. And also it kind of does rob the students of the experience to some extent. So another way you could do it is you could actually create a jig that holds this piece securely in it. And also, it's a jig that you can flip over. So, for example, when you're cutting, this part here, you can then go and flip it to cut, up the hill, down. It's sort of hard to explain here in a slideshow, but you can actually sort of flip it over. The other thing too is, I'm just trying to think of other ways you can make this process safer. The obvious one is make sure you've just got a nice sharp cutter in there. Another one is make sure you're using a species of timber, like how I described this tear out. I know some species are quite prone to that, and other species, if you've got a nice cutter in there, that won't happen or won't be that much of an issue. But the main one that I would definitely use in this case is create a jig that can hold the job securely in it, and then the hands are away from the cutter, and the student can control the jig rather than having to control the piece itself. One of the negatives of that is that it then does not allow for individual changes generally. So if a student designed a handle which had a different length to it or something like that, it might not work in that jig, because usually jigs are very specific for specific dimensions. So they're just some things to consider as you then develop a safe work method statement for the router, and particular, as I mentioned in assessment task 2, for this particular process here. And it's certainly something that you can talk to Dave about on Monday night.